you think is the purpose of the spines on the prickly pear? I'm going to be calling volunteers unless you'd like to volunteer yourself. Yes, buddy.
I said to scare off animals that want to eat it.
To scare off animals that want to eat it. Does anybody else have any other predictions? One more person. Tyler.
Not to scare them off, but to injure any animal that tries to eat them.
That's a good prediction. To injure them so they don't get eaten, right? Okay, so the possible purpose for spines are the defense mechanism. This cactus finch was likely foraging for food or water when it met its fate. Does everybody see that finch that's on the cactus? No, it's a very sad sight. But that's its defense mechanism. Also, another possible purpose for the spines is for the spreading of seeds. Prickly pear cacti attach easily to animals, helping them spread the cactus seeds to more places. Have any of y'all been walking around in grass and y'all get little stickers in your shoes and then they get stuck on your carpet? Yeah, that's basically the same mechanism. You're trying to go somewhere. Alright, so for the next two questions, which are on the back of your entry ticket, you're going to turn it, talk to your neighbor, so everybody can talk to their shoulder partner. Discuss and answer questions 2 and 3 on your entry ticket. You'll have 4 minutes to answer. So go ahead and go.
Shoulders.
Shoulder partners, yeah.
Alright, how many spines of ones that is prickly pear?
You guys want that one? We'll take this one.
Okay. Oh wow, there's so many.
Wait, we're counting. I count one and you count one?
Yeah, you can have that first.
Also, can I get everybody's attention real quick? Don't flip over or touch the prickly pear pads. It's fine.
Do you remember?
Say what?
Do you remember any number?
I was kind of just having the note and stuff, but it says actual spines.
Able to see a difference?
Just the spine, right?
Mm-hmm.
I got like 30.
Okay.
They do scary
I
animals.
guess you say 30.
It's more likely that it's catch them.
Two baby.
What differences did y'all notice?
This one had more spines than this one.
How many spines does this one have?
Beak.
Well, it's a cat, so.
This one's better adapted
70?
because there's more spines.
Well, we counted.
We counted the things that were still attached. Do we count the wrong thing?
Just whatever you observe. Y'all have 2 minutes left. Raise your hand if you have any questions about the directions. Tyler, what'd you write down?
Oh, like we just counted the spines, and then we take the one that has this one that has more, has better chances for mine.
We have another few things to do.
When you're finished, put your pencil down.
These, I guess, were shot.
spines than the other one.
Right, why do you think one has more spines?
They were knocked off,
They might have been knocked off.
or they were just made, or they grew with less spines.
So the two individual species were, not species, organisms were different. Okay. One more person. Alexis, what did you write down?
I said that the pad with 12 spines seems to be better adapted because the defense mechanism is present in greater numbers.
Right. So why do you think its survival is better? Like what's it protecting?
I think that it could be more useful to have more because if some of the spines get knocked off when an organism comes to feed on it or sit on it, if there are still more spines left behind, it'll continue to be protected.
That's a good prediction. Alright, so our objective for today is that students will be able to explain variation within a population or species by comparing external features and behavior of organisms that enhance their survival. So in your last lesson you learned that all individuals are different. Now, what's that? So now we're going to go into how does that help individuals if they are different? Is there any survival advantages to that? So, our activity is called Eat Like a Bird. So, find and sit next to your partner. Monique and Taylor, y'all are going to be together. Alexis and Kristen, y'all are going to be together. Jennifer and Sarah and Tyler and Easton. Or Tyler and
Changed again. So you're better dressed.
Alright, so I'm going to go over the materials that each group is going to have. Each group is going to have 2 cups, 1 large clothespin, 1 small clothespin, and 2 exploration guides. So I'm going to go ahead and pass these out. Take them with you. And we'll be working at this back table over here. So, for clarification, each person is going to be either going to have a large clothespin or a small clothespin, and you can't change them out. Alright, so for the directions, the pins, let's go ahead and just pick an environment. So everybody stand up, and go pick one environment. Stay there. So each of y'all have some pins, like some clothespins, set in front of you with a cup. So it says the pins you have represent mockingbirds with the same species. One of you is a mockingbird with a small beak, and the other is a mockingbird with a larger beak. Using only your beak, you will have 20 seconds to eat as much food as you can, and that's going to be either your sunflower seeds, your rubber band worms, your corn kernels, or your beans. Then you'll have 20 seconds to record how many seeds you and your partner ate. So on your exploration guide, there's a chart. You're going to record how many seeds you ate, or rubber bands. You're going to record how many seeds each mockingbird in your group is able to pick up on your exploration guide. And right here is just an example. These aren't real numbers. We just made up those numbers. Y'all are going to probably get different results than that. Okay? Alright, so your expectations for today are: do not throw or eat the bird food. Do not pinch each other with the clothespins. When the teacher says time's up, the recorder will write down how many seeds you collected and return all materials to the materials mat. So your materials mat is right here. It's this piece of paper that says your environment's name. Okay. Wait for directions to move to the next habitat. Right? Alright. So I already picked out your environment. Ready, set, eat, and go. 20 seconds.
to be one. Yeah.
They should have.
What would help? Interpretation is peak external. External. Oh, sorry.
So the beach house, you guys did 4 hours of water fixed. Beach house.
Okay.
Oh,
Figure we could do that.
Because it's
Yeah.
the appearance.
the
Yeah.
small movers.
If you finish early, go ahead and put your pencils down so I can see who's done.
Very
Beach house.
size.
External.
I agree. That is something that we can observe to experience.
Alright, you'll have about 1 minute. Is everybody finished? Alright, so we're gonna go over the exploration guide first before we move on to explain. So, for 8A, David, which beak is best adapted for survival in the desert? Explain your answer and use evidence collected during your activity.
The small beak,
Why do you say the small beak?
because it ate more food items.
Okay. So, for 8B, Sarah.
The large beak, because it collected more food.
Okay, so where did the large beak collect the most food at? Everywhere?
Ours was different.
Ours is different.
Large beak collected less in the hill country.
And David, did your small beak collect more food in one place than in a different place? Like theirs did? It did? Okay. And for 8D. Jennifer.
I think it's external because it's a physical characteristic.
Right. Okay. And there we go into explanation.
Okay, everybody, you can hold on to your exploration guide, but I would like you to turn in your entry tickets to me.
Mr. Barry.
Yes.
That's Tyler's.
Oh, you did. I'll give it back to you afterwards.
Austin, you changed it.
Okay. Here you go. Everyone, there's a data table at the top of this sheet here. We're gonna fill it out as a class, so I need all of the recorders to come up to the front of the board, okay? Bring your exploration paper with you. Exploration guide with you, because you have your data written on there. All the recorders to the front. Can you write your number? Small, large. So not one, that's the large beak, small beak. No, this is you, those are your first ones. this one, you have environment 1. Okay, great. Just like that.
I'm done. Or do all?
Make sure.
We're gonna do all of them. And then we want to environment 3. We're all gonna write in our numbers for each environment and for each week type. And we're gonna total them up. That's why you know our numbers. There you go. We're just gonna cycle through. That's why it's important to be a good reporter. And while you guys are oh, okay, cool. Where is it? While you guys are waiting for them to input that information, can you try answering question number 2 on your own? I can do it in my head. There's reporters, as you return to your seat, go ahead and answer number 2 on your own. And Tyler, when you get back to your seat, go ahead and start answering question number 2. My mental math took a little longer than I thought, guys. Okay, variations to survive. You have your explanation guides. Awesome. Okay, according to our data, which beak is best adapted for survival and overall? We're going to change the question to which beak is best adapted for survival overall. You can go ahead and take a look at our class data table that we completed on the board. Do you have an answer, Jennifer?
The large beaks,
The large beaks? Why do you say that?
because more of them, like there's only one small beak that won or had more, whatever the organism was that it ate, and all the 3 large beaks had more.
Okay. Are you saying that the large beak was able to eat more food in multiple environments, whereas the small beak was able to eat more food in only one environment? So it was best adapted for only one environment versus 3?
Mhm.
Okay. And what was environment number 4?
Grasslands,
Grasslands? Okay.
I think.
No,
No, beach.
Beach. Okay. Alexis, can you read the question on the board for me, please?
How do you think it affects an individual's survival if it can eat a variety of food types versus an individual that can only eat one type of food?
Take a moment to think about that. And Tyler, what do you think based on our class data? The question's asking, do you think it's helpful for an individual to be adapted for multiple food types? Or do you think that it would be better to be adapted to only one food type?
Multiple food types.
Multiple food types, why do you say that?
Because if you're only adapted to eat one food type, if you can't get that one food type, you're done.
Can you think of a situation in which that might occur? For example, for birds that eat corn.
Birds that would say can only eat, say, something the size of a rice grain. If they move to an area where there's like stuff the size of like corn kernels, they wouldn't be able to eat it.
What if they couldn't move, right? So they were in one habitat.
Mhm.
Can you think of a situation where their food type might disappear?
Something else either eats it, or like the plants stop producing the food, or they get burned in a fire or something.
Burned in the fire.
Yeah.
I was thinking something maybe like a drought.
Mm-hmm.
That might help too. And what did we say? What type of adaptation is beak size? External, behavioral, or both? Taylor, what did you have for that one? That was the last question.
External.
External, why do you say that?
Because they are varying in size, which is a physical trait.
Varying in size, which is a physical trait. Okay. Do you think that they can change their beak size?
No, they're born with that.
Let me reword that. Do you think an individual could change? Does that change your answer?
No.
Okay, no. Great. So beak size is an external adaptation. Beak size is a trait we can physically observe. So all organisms have traits that help them survive in their habitat. We talked about habitat before. That's something that you should have learned in the 4th grade. But can someone please tell me what a habitat is, Sarah?
Where something lives.
Where something lives. Okay. It's like its house. We have a photo here of a habitat. It's a cave. Can you think of something that might live in a cave? Sarah?
Bugs.
Bugs. Does anyone else have another answer?
Bats.
Bats, yes. Bats also live in caves.
Parakeets.
Oh, we also have the word trait. That was from last lesson, actually. So using the organism that we looked at in today's Explore, what was the trait that we focused on, Tyler?
Beak size.
What was that? Say it one more time.
Beak size?
Beak size, yes. Here, I have a photo of some corn. This corn is all the same. It's all corn, but they have different traits. That's why there's a picture of corn there, okay? Just to help you remember that. So habitat, traits, rasgo. For our Spanish speakers. Okay, take a look at number 3 on the explanation guide. And I'm going to give you guys 1 minute to match the review words. Ready, set, go. So you're just drawing an arrow from the word to the definition. It looks like you figured that out. Okay, once you're finished, put your pencils down. And Kristen, can you tell me what you got for adaptation?
I said it's a characteristic or behavior that helps organisms within the same species survive.
Within the same species survive. Okay. What about for species? Sarah, what did you get for species?
A group of the same type of organisms that are able to reproduce with each other.
Okay, and again, that's what we looked at last lesson. We were looking at species. You can double check up here and make sure that your explanation guide is correct. That way you can use it to study later. To sum that up, traits that organisms have can vary between individuals, and sometimes these traits can help an organism survive better than others. So we talked about the bird beak being a physical adaptation that cannot change. Well, there's another type of adaptation that falls under 2 categories. 2, that can change and that cannot change. But we're going to focus on behavior. So we can change our behavior, right? What do you guys think of when I say the word behavior? What do you think of, Jennifer?
The way something acts.
The way something acts. Okay. So you can change your behavior But first I want to focus on something that you're born with, a behavior that's like an instinct. Is this something as well? Oh. So we have our behavior, the way in which an organism reacts in response to a stimulation. We were all mockingbirds during our exploration, so let's talk about a behavior that mockingbirds use to survive. Have you ever walked by a mockingbird nest? No. Tyler has. Okay. Did anything happen to you when you walked by the mockingbird nest?
They're aggressive.
They are aggressive, yeah. So aggression in mockingbirds, what do you think that might be? An external, internal, what was question number 4? External, behavioral, or both? What type of adaptation would that be? External, behavioral, or both? That would be behavioral. Why do you think it's helpful for a mockingbird to be aggressive? To protect its. Okay, it's young, it's self. Explanation. And number 4, is that the same question? Another, what, how does an adaptation? Oh, great, sorry. Number 4. Okay, sir, could you read number 4 to the class, please?
How does an adaptation for aggressive behavior make different individuals of mockingbirds more likely to survive?
Okay, so think about a mockingbird that isn't aggressive versus a mockingbird that is aggressive. And answer the question. Monique said to protect their young, also to protect themselves. Probably also good if you're fighting for food, right? Another behavior I'd like to touch on is one you've probably heard of and you've seen in bears, or not seen because they disappear. Hibernation. Does anyone know about hibernation? Can anyone tell me why bears hibernate, Monique? They sleep for several months during the winter. Do you know about any other animals that might share this behavior? Or this adaptation? If you don't, it's okay. Alexis, do you know one?
Some insects may overwinter.
Yeah, that's true. Alexis said some insects may overwinter. Can you think of something that may hibernate overwinter?
Ticks will overwinter
Yeah.
a lot of the time.
Okay, so if you think about the animals that eat insects, they might be affected when their food type disappears, right? A couple of the other insects and organisms that hibernate, we have the honeybee. So this is actually what I was talking about. So the honeybee, it gets too cold for the honeybee during the winter. So they huddle together around the queen, head facing towards the queen, and they keep the hive warm. They actually eat the honey over the winter, only the ones that have access to the honey. And so some die protecting their hive. So when the honeybees disappear, that's not... Okay, so let's specify, not all bees hibernate, but some honeybees do. And that's the same for the bats too. Not all bats hibernate, but those that do live in high altitudes or that eat insects will hibernate. But for the ones that don't, they have a different behavior for adaptation, which is migration. So bats will migrate. Can anyone explain what migration is? Taylor?
Moving from one area to another.
Yeah, moving from one area to another to escape, in this case,
The season.
Here's another organism that migrates. This is a monarch butterfly. This is something that you might have seen actually. If you look at the picture on the right, it shows the pattern from which they're coming from. And see how they're coming from the north towards the south? a misconception that we should address is that learned behavior is not an adaptation. Not the kind that we're talking about. Think about learned behaviors as something like training a dog to fetch, a raccoon digging for food in a trash can, or a cat learning to use a litter box. Why do you think that a learned behavior might not be an adaptation? Alexis. Oh, Sarah. Sorry.
Because you can't pass those down
What do you mean you can't pass them down
to your offspring.
to your offspring? Can you think of another example of a learned behavior? I was thinking, if you work out a lot, if your dad or your mom is really buff, does that mean that you're going to be really buff?
No.
No. Okay. Can you think of something else? Maybe a learned behavior?
Maybe if like you take singing lessons.
Oh, nice. So if I learn how to sing really well. Okay. So animals and plants are born with adaptations. They cannot learn them. I want to show you guys one thing. I want to go back just for a second, because Tyler says he's seen a mockingbird being aggressive, but this is a video of a mockingbird being aggressive. So this is a cat lounging around, and do you see how it's diving? The nest is probably, where do you think the nest is?
In the tree.
In the tree, yeah. It's probably just a little too close to the nest. It looks like the cat's not having a good time with it. I watched several of these cat videos, and this is the most exciting mockingbird cat video. Most cats just kind of swat it away. But I do think it's an effective guard against their young, before they're young. Did everyone fill out all of their explanation guide? It looks like you did. Here's a misconception. So now that we've gone through the explanation, I want to give you guys an evaluation. And when you're finished with it, you'll just turn it in. Anything that doesn't have notes on it, on the scribble.